Good evening. I'm Spot On Weather meteorologist Matthew Euler, and welcome to the Teleconnections discussion for 15 January 2021. On the opening slide tonight, I am showing you what a typical polar vortex split, what type of patterns it sets up after a typical polar vortex split. Now we have a split going on right now as I'm making this video here in January 2021, and you'll notice a couple features there on the left hand side with that maroonish coloring. That is abnormally high heights at about 18,000 feet in the atmosphere. That's known as an upper level ridge, and downstream of that ridge you get that deep blue colors over the Midwestern and Eastern United States, and that is known as a trough, or anomalously lower heights at about 18,000 feet or 500 millibars. You'll notice how the blue extends all the way up into the Arctic. And so that's an extremely cold and frigid air mass when you get a connection all the way up to the North Pole area, all the way down into the lower 48. So I just wanted to start tonight's video by showing you what a typical polar vortex split, what type of pattern usually sets up. So let's go ahead and get right into tonight's discussion. There's a lot to talk about again this week. Looking at the Madden-Julian oscillation, or MJO, the phases and the areas of enhanced convection, showing phases 1 through 8. That's generally how the MJO is classified, phases 1 through 8. And you'll notice, as I mentioned in previous videos, where the enhanced area of convection sets up across the equatorial parts of the Western Pacific into the Indian Ocean. For example, if we have phases 2 and 3, you get convection in the Indian Ocean. And in fact, right now, and I'm going to show you here in a moment, we actually are in a MJO phase 3 at the present time. And that's where that'd be associated with that convection or that thunderstorm development over the tropical waters of the Indian Ocean. On the other hand, if we were in phases 4 and 5 and 6, those are generally associated with warmer phases as far as temperatures across the eastern United States are generally warmer when you get the enhanced convection over Australia in phases 4, 5, and 6. And then the colder phases are usually 8, 1, and 2. So really interesting stuff. I'm going to go ahead and go into the temperature composites on the left here for the MJO for the months of January, February, and March. And the blue shading represents below normal temperatures. The orange shading represents above normal temperatures. So blue below normal and orange above normal. All right, and again, just as a rehash, a review of things, phases 8, 1, 2, and 3 are all associated with colder temperatures across the eastern United States. And in fact, you could say phase 2 and phase 3, the colder air, the blue shading for phases 2 and 3 on the left, correspond to colder temperatures pretty much across the entire United States, from the west coast to the east coast. On the other hand, phases 4, 5, 6, and 7 are associated with warmer temperatures across the eastern United States, especially phase 6. If you look at that on the left-hand side there, the graphic, notice that deeper hue of orange. That's associated with very much above normal temperatures. Looking at the actual forecast now, moving into that, the GFS ensemble forecast on the right, pay attention to the green line. That is your NCEP GEFs, showing the MJO currently in a weaker phase 3. And the green line moves right back into the null phase towards that smaller inner circle. And I've explained this diagram before in past videos, but the smaller inner circle on the diagram generally correlates to a null phase. What does that mean for us in the eastern United States? That means that the temperatures, the MJO really doesn't favor warm or cold temperatures in the east. So generally we're looking at a weak phase 3 moving into the null phase, the center of the diagram, the inner circle. Meanwhile, the GFS operational MJO forecast is showing, pay attention to the aqua color line there for this particular image. It's generally in a weak phase 3, so that matches up fairly well with the overall, with this GFS ensemble forecast. But notice how the aqua line goes as well back into the inner smaller circle, back to a null phase. So again, what are we expecting out through the 29th of January? Almost all the way to the end of January, we're expecting MJO to be in a weak phase 3, transitioning to a null phase, to weather So basically there are no colder or warmer temperatures favored in the Eastern U.S. Let's take a look at the La Nina update, as we do every week, so very important. We are still in a La Nina year, and the water temperatures have pretty much been steady over the past week in the equatorial Eastern Pacific. There's a box that's known as the Nino 3.4 region, and our temperatures indicated there by the blue shading. The graphic on the left show blue shading indicates below normal water temperatures, while the orange shading represents above normal water temperatures on the temperature anomaly chart in degrees Celsius on the left. So look at the graphic on the right now. That shows the ray trace, basically. The blue line shows where the water temperature departures have been going back to late October and where they are now, here on January the 15th, 2021. Right now we're looking at a water temperature departure in the Nino 3.4 region in the eastern equatorial Pacific at -1 degree Celsius. Now, just to rehash the classifications of La Nina, all right, if you're between a -0.5 and a -0.9 degrees Celsius temperature departure, that is classified as a weak La Nina. Meanwhile, if you're from -1 to -5, you're in what is known as a moderate La Nina, and that's basically right on the border between weak and moderate La Nina at this point in time. If you go stronger than -1.5 degrees Celsius, by the way, if let's say that blue line on the graphic on the right, if that dipped below 1.5 degrees, -1.5, like it did in late October, early November, that would be classified as a strong La Nina. All right. Let's move into the teleconnections now. Really interesting stuff. Been watching these very closely. These have a huge bearing on the sensible weather. Here's a look at the Arctic oscillation, and I show this every week, showing you the difference in the pattern, the upper air pattern between a negative Arctic oscillation and a positive Arctic oscillation. Notice the graphic on the left with a negative AO. You get more of a stronger dip in the jet stream. All right, the polar front jet. The coldest air really spills up out of the Arctic with a negative Arctic oscillation. You'll get what's known as a Hudson's Bay Polar Vortex. With that, you get cold air basically circulating around that polar vortex and much colder air brought down to the Midwest and the Eastern U.S. On the other hand, on the right-hand side, you see a positive Arctic oscillation, or AO. And this is associated with pretty much a strong, fast jet stream that generally the coldest air remains well up to the polar areas to the north. Even above the U.S.-Canadian border with more of a positive Arctic oscillation, you get milder west to east jet stream winds, basically coming from the Pacific Ocean. So let's take a look at the models and the forecast for the Arctic oscillation. This is a look at the European deterministic from today. Pay attention, just a quick reminder, the blue line is where the Arctic oscillation has been in the past, and then you'll see these white circular lines, and those are the forecast lines, okay? So looking at the forecast, European deterministic AO, between now and 25 January, it remains negative, all right? Looking at European EPS, AO 50 perturbed members, this one goes out to the end of January pretty much, around 30 January. Pay attention to the green line, that's the ensemble average. So we have 50 perturbed members of this particular European EPS, and the green line represents the average of all those different variables in the outcomes. And so the green line staying below the zero line, well below the zero line, all the way out through 30 January. So that's a negative AO on this model. European EPS, AO, 50 perturbed members, this one goes out further, out 46 days. This again, as a reminder, this particular model, the 46-day, tends to have a positive tendency in the longer range, I've noticed. Look at the green line, that shows again the ensemble average, and look at how low that green line is, and it doesn't get to neutral until around the 16th of February, and then eventually slightly positive after that. So a negative AO, noticing the theme here? Looking at the GFS deterministic AO forecast, the white circular line there, again, negative AO, 15 January today, all the way out until it looks like it's about the 29th of January before it transitions positive. But this model, GFS deterministic, has shown signs of the AO going positive, but then it corrects usually back to negative. So I'm taking the end of this particular forecast with a grain of salt. And then the NCEP-JEFS V12 AO 30 per term member 16-day forecast out to the end of January, 31 January. Green line staying well below that zero line in the negative territory, so a negative Arctic oscillation. All right. So that's the AO. Now let's take a look at the North Atlantic oscillation. Wow, what a pattern we've had for quite a while now, with a very strong Greenland upper level ridge, a strong Greenland block. Positive NAO phase, that shows you what the general jet stream setup looks like. With a negative NAO phase on the right, that's what we've been seeing. We've seen this huge ridge into Greenland and the North Atlantic, and now we have an actual strong ridge over on the Pacific side as well. So we got two huge strong ridges on both the Pacific and the North Atlantic sides of the Northern Hemisphere right now. So let's take a look at the European deterministic NAO forecast. Notice the white circular line staying in the negative territory. Negative. Goes even further negative around the 24th to 25th of January. All right. The European EPS NAO 50 per term members 15-day forecast out to 30 January. Green line, average ensemble mean, right? The ensemble mean staying negative again. So we have a negative NAO on this model through 30 January. Looking at the European EPS NAO 50 per term members out in 46 days, out to around the 1st of March actually. And look at the green line there, the ensemble mean or average showing a negative tendency to the NAO through the 20th of February, all the way out to the 20th of February. We're looking at 35 days from now, 36 days out, still negative. Impressive. Very persistently negative, I must add. Eventually, this model shows NAO transition to neutral conditions. How about the GFS deterministic NAO forecast showing a negative tendency, eventually just like the AO, showing a neutral condition, transitioning to slightly positive after 30 January. Again, I take this with a grain of salt because I've seen the last 2 weeks how this model tries to make it positive and then it goes back to negative. And then finally, the NCEP-JEFS V12 NAO 30 per term members. This forecast is out to the 31st of January. Oh, the green line staying negative. You're getting the hint here. So we have a negative AO, like I briefed it last week. We have a negative AO, negative NAO. Now let's look at the PNA forecast. With the PNA, we do have some changes to report with this week's video. The image on the lower left shows a typical positive PNA graphic where it's below average temperatures focused across the Eastern U.S. with a positive PNA, the above average temperatures over the Western U.S. More of a ridge, upper level ridge over the west with a positive PNA, and a trough over the east, especially east of the Mississippi River. The graphic on the bottom right shows a negative PNA average conditions with a more of a southeastern ridge trying to pop in here and above normal temperatures for the East U.S. Out in the Western U.S., you have below average temperatures over not only the Western U.S., but also up into Canada. So things are getting interesting with this. So let's take a look. European deterministic PNA forecast out through 25 January. You notice how it's positive. It's above that zero line in positive territory, the forecast, until about the 19th of January. Coming up here, that would be this upcoming Tuesday. And then it drops negative, and pretty significantly negative. Moving on to the European EPS PNA forecast. This is 50 per term members out to 15 days. Look at the green line showing a positive PNA through 19 January, but transitioning below the zero line in a negative territory. European EPS PNA 50 per term members 46-day forecast out to the 1st of March, showing a positive tendency initially on the left-hand portion, around positive 2. Down to 0, though, around the 19th, and then down to negative territory from about 19 January all the way through 1 March, according to this model. Looking at the GFS deterministic PNA forecast, showing positive tendency of the PNA, and this is saying the same exact thing. Right around the 19th of January, we're transitioning to a negative PNA. And then finally, the NCEP-JEFS V12 PNA, 30 per term members, 16-day forecast out to 31 January. Notice a positive PNA, the green line. That's about through the 19th of January. There's a very common theme here amongst all the models, pretty good consensus, transitioning to negative PNA after the 19th of January. Moving on to the Eastern Pacific oscillation forecast. The graphic on the left shows a negative EPO pattern, and the graphic on the right shows the positive EPO pattern. So look at your differences. The main differences between the negative EPO and the positive EPO on the right is you see upper level ridge building into the Gulf of Alaska with a negative EPO. And with a positive EPO, you get a major, the Aleutian low going there around the vicinity of the Aleutian Islands. And so you get a major area of low pressure in the Gulf of Alaska with a positive EPO. So pay attention to this. Notice with a negative EPO, you get Arctic highs and we get the upper level ridge to build into Alaska. Those heights rise, and eventually what goes up must come down. So you get that much colder air coming down to the United States with a negative EPO. The much bigger dip in the jet stream. While with a positive EPO on the right, you notice how it's milder. You get more of a west-east zonal jet stream, keeping mild Pacific air over the lower 48. So big differences here. What about the models? European deterministic EPO forecast. This goes out to the 29th of January, or actually 25th of January. Wow, this was like a roller coaster, doesn't it? Up and down, up and down, up and down. So with the European deterministic, we're looking at eventually going down to negative territory. It's positive through about the 19th of January, then it transitioned to negative. European EPO, 50 per term members, 15-day forecast. This is out through 30 January, showing a positive EPO through about the 19th of January, and then turning negative after that for quite some time too. Moving on to the European EPS, EPO, 50 per term members, 46-day forecast out through 1 March, showing a positive EPO, becoming negative in late January, and then coming back positive after, it looks like about the 28th of January through 1 March in a positive state. And the GFS deterministic EPO forecast showing, again, kind of a roller coaster here between the 15th and the 20th of January today and the 20th, and then it drops significantly negative after the 20th. And finally, the NCEP Jeffs V12 EPO 30 per term members, 16-day forecast out to the 31st of January, showing positive EPO, then it crashes negative, especially around the 22nd of January. And it remains negative, though, all the way to the 29th of January. All right, moving on to this very interesting subject, the polar vortex. Okay, this thing is split. It's split into 2 separate vortices. And I'm showing you a different graphic tonight for this to really hone in on a couple points. All right. As we started with the opening slide, we saw what a typical split polar vortex, what type of pattern in the United States that results in. You get a deep trough in the Midwest to the East Coast. You get much colder air, below normal temperatures. You get more of a ridge out west with milder temperatures. So if you look at the graphic on the left, that's today. You see the maroon and orange shading and how it's centered over the North Pole. See the green shading on the image on the left? That is where the coldest stratospheric temperatures are. Now we're looking at these up at 10 millibars, the level here on these charts. So we're not at the surface. We're up way high up in the atmosphere at about 10 millibar level. This is the temperature anomalies in degrees Celsius, by the way. That's what we're looking at. All right, so the green shading correlates with below normal temperatures in the stratosphere. The maroon or orange shading above normal temperatures in the stratosphere. So we had what's typically known as a sudden stratospheric warming event in the stratosphere. And this is when you get anomalously warm temperatures to move in the stratosphere. The stratosphere dramatically warms over the North Pole. And so you see the positioning of the green on the left there. That's the coldest stratospheric temperatures. The graphic on the right shows the forecast for 31 January, the end of the month. This is the GFS model, by the way. I've been paying attention to the GFS, the Jeffs, as well as the European model on where this green color goes. Now, the purple shading on the image on the right is even colder temperatures or departures from normal. Okay, so what do we have? What are we observing here? We're observing a lobe of the polar vortex, that green shading. And that's rotating basically from Eurasia into the United States by early February. And if it does this, we could see potentially very cold air to come down from basically with this polar vortex lobe. This is a chunk of Arctic air that normally resides well to our north, over the North Pole. So when you warm those higher latitudes, you get a split polar vortex with a sudden stratospheric warming, which we have now. And it's something that we got to really keep an eye on in the longer range is what I'm getting at, because it has the potential to become very cold. Research has shown that it takes 2 to 4 weeks after a polar vortex split before the eastern United States really gets cold. So this is, again, something we're going to watch really closely. I'm keeping an eye on this one because this could really have a big say in how late January into February, what it feels like. All right, so moving on to the final thoughts for tonight's video. The MJO, we looked at that. It's currently in phase 3, transitioning to null phase, right on through the end of January, pretty much, through 29 January. Phase 3 indicates those colder temperatures across the entire U.S., not just the East, entire U.S., which I'm kind of seeing a phase 3 look right now. Now, the null phase, if it goes back to that inner smaller circle on the diagram we looked at for the MJO, that's going to indicate minimal impacts. That's not going to favor warmer or colder temperatures. So here's the bottom line with MJO. It's remaining very inactive. Second thing, La Nina conditions continue. There's no doubt about it. We do have those temperature departures. The water temperatures are below normal in the eastern equatorial Pacific. We see that. Right now it's about 1 degree Celsius. Water temperature departures below normal in the Nino 3.4 region. Now, anytime you have a La Nina, you have to say, okay, this favors mild temperatures across the eastern U.S. and mid-Atlantic. It's just a fact. It's been studied. However, this isn't a very strong La Nina. I keep mentioning this in every video I do. So I'm not really expecting a major impact from La Nina this winter, the rest of the winter. I just don't see it. Next, the models are indicating that negative trend in the AO, the Arctic oscillation, through 29 January. That would indicate colder temperatures in the eastern U.S. Models are indicating that negative trend in the North Atlantic oscillation, the blocking to continue into Greenland all the way through the 29th of January, and that would indicate colder temperatures in the eastern U.S. Models are indicating a negative Pacific North American pattern, PNA, after 19 January. Now, this one, to me, this negative PNA is going to, what I'm seeing in the models anyway, it's working to redistribute the cold air to not just be confined to the eastern U.S., but to spread back towards the western U.S. With that negative PNA, you'll get troughing out in the western U.S., and I'm seeing that in the models. I watched it all week in the trends and temperatures, and the models are showing almost what appears to be a zonal west-east jet. There's a lot of competing factors going on with the atmosphere right now. But if we get the negative PNA, you would say, okay, we're going to have a southeast ridge. We're going to get milder in the eastern U.S., especially the southeast and mid-Atlantic. The models are also indicating a negative trend in the Eastern Pacific Oscillation, EPO, after 19 January. Now, this is important because now we're putting a huge ridge, which, having a ridge in the Gulf of Alaska and rising heights all the way up to the high northern latitudes on the Pacific side, what goes up, again, must come down. So typically you get a trough or the jet stream to make a major dip from the Arctic area down into the lower 48 in the eastern U.S. when you get a negative EPO. You get more of what's known as cross-polar flow. So we're really going to keep an eye on that for that trend. The models are indicating a splitting displaced polar vortex. It's already split, folks. It's already split. And one of the lobes has been over around Eurasia and, impacting Europe as well. Madrid, Spain had one of their biggest snowstorms ever in their history. There's been some very cold temperatures in some parts of Europe. And now, again, I'm keeping an eye on where does this lobe, the green shading, where does that end up over time? All right? So something to really keep a close eye on. Now, with the splitting displaced polar vortex, typically gives you those cold temperatures across the eastern U.S., right? But this may be delayed. This may not occur right away. So, like I've been watching the models this week, and I've noticed where's this polar vortex at? You Google polar vortex and you look at all the articles and how it says, oh, winter's going to get just freezing cold, and it's going to be, it's going to be a severe end to winter here, right? It's going to be a severe second half to winter. All you see that, you see all that with the polar vortex if you Google it. Just Google it tonight, and you'll see all these articles of the polar vortex. And you look at the models this week, and you say to yourself, where is it? Anyway, bottom line and moral of the story is we're keeping an eye on it, and it's typically a delay involved on the order of 2 to 4 weeks after a polar vortex split before the Eastern U.S. may actually see the impacts from that and the colder temperatures. So I hope that makes sense. All right. Overall assessment, the Madden-Julian oscillation MJO favors colder temperatures across the entire U.S. in a phase 3. But then as it goes to null phase, we'd expect very little impact. The La Nina, it remains weakly moderate at a minus 1 degree Celsius departure from normal for the water in the Eastern Pacific. Now the AO and NAO, they remain negative over the next 2 weeks, and they have been negative for quite some time going back to December. Really persistent negative. Now there are big changes in the PNA. Now that may be responsible for the forecast of colder temperatures in the western U.S. If you look at the short range models right now, showing colder temperatures basically from west coast to east coast. And if you were to draw a line around 40 degrees north latitude and just follow it from the east coast all the way to the west coast, there would be cold Arctic air north of that line, and then there would be somewhat milder air south of that line, the 40 degree north latitude parallel. All right, so that's the way I see it right now. The MJO is in phase 3, and I'm really seeing it on the temperature distribution across the U.S. Also, with the PNA going negative, I've seen some of these longer range models trying to take the coldest air back into the Pacific Northwest with a negative PNA. And so we're going to have to keep an eye on that. Now, the one thing that could possibly offset that negative PNA is a negative EPO. It's looking more likely next week. And so here's the thing. With a negative EPO, we have a huge ridge in the Gulf of Alaska. That ridge builds, the heights rise into western Canada, and then on the front side of that ridge axis, you get colder, much colder air filtering southeast along, just ahead of that ridge axis and forming a long wave trough downstream of that ridge axis. So that negative EPO, that might be something that contradicts or offsets the negative PNA. And I'm really curious to see how that turns out. Meanwhile, the polar vortex, those impacts may not be felt until the last few days of January into early February. There's 2 teleconnections that are indicating milder temperatures now on tonight's overall assessment, while 4 teleconnections plus the polar vortex say colder temps for the Eastern U.S. So we're going to have to keep a close eye on this and see how things really, really turn out. Okay. Additionally, I'm going to expect, well, first let me get to this. There's a huge battle going on with this anomalous ridging in the high latitudes. There's just this crazy ridging going on both the Atlantic and the Pacific sides. In fact, some of the models earlier this week were showing a huge upper-level ridge from the Pacific side meeting the huge upper-level ridge on the Atlantic side from Greenland and meeting over the top over the North Pole. So there's some really anomalously high-latitude blocking going on both sides right now. So it's going to be interesting, that big battle between those anomalous ridges in the high latitude versus the subtropical ridge in the lower latitudes. Now, I have noticed this past week how the southeast ridge or subtropical ridge is trying to pop northward and bring those thickness values and warmer temperatures north. And so that's something you got to keep an eye on. Right now, it appears that due to such anomalous ridging over the top at the high latitudes, it seems to be squashing or pushing the Arctic colder air south and squashing the southeast ridge a little bit. So that is another thing really I'm going to be really curious how it turns out. Here's the bottom line. We've got a lot of changes going on in the atmosphere. I would expect to see continuous changes from model run to model run. I've witnessed so many changes this week in the models. I'm sure if you follow the weather closely, you've seen what I'm talking about. How it goes from a milder look to a colder look to a right on the border look. Potentially, we could see much colder air from New England into the mid-Atlantic with frequent storm systems. They may not be strong storms. They may be weaker systems that kind of pass through from time to time. There is potential, there very well could be a stronger storm system in the future here in late January. But what I will say is, looking at today's models anyway, you pretty much have a west to east orientation of your thickness lines. With the 540 thickness line, which is typically your rain snow line, sitting over right around Hampton Roads or possibly a little bit further north into central Virginia. And all it takes is for a storm system to develop. We're on the baroclinic zone, which is that strong boundary between warm and colder air. So we're in the right area for potential storms in the mid-Atlantic. But all it takes is for a storm system to really crank up, and on the backside of that storm system for the gradient to tighten, and we get much colder northerly winds on the backside of the storm. And so that's very possible too, and that's why I say it could be potentially much colder. One other thing I want to mention tonight from the models that is really intriguing to me is I've been watching this, and even NOAA just put this out tonight for the longer range 8 to 14 day temperature outlook for below normal temperatures from New England to the mid-Atlantic. It looks like much colder air is going to come down from eastern Canada down the east coast, potentially the last week of January, and I'm keeping a really close eye on it because it's pretty cold where the winds are coming from. It looks like a more persistent northerly wind, a little bit of a stronger gradient, blowing in much colder temperatures. And if you get a storm system just on the southern route to meet up with that kind of cold, on the northern side of that storm track, you could get some wintry weather and snow across the mid-Atlantic. So that is something definitely to keep an eye on. All right, that wraps things up tonight. I appreciate you subscribing to the Spot on Weather YouTube channel. Again, a lot of excitement. I'll tell you, I'm excited because there's so much going on, and just watching these models from run to run change. If you want, winter weather for especially like Hampton Roads is in a snow drought here. If you want winter weather, it's going to be really maddening watching these models. You could be excited one model run thinking, oh yeah, we're finally going to maybe get some snow here if you want a good snowstorm. Then the next model run, you look at it and you say, where did winter go? Why did the Southeast Ridge build so much? And so that's what we're looking at right now. Overall assessment, I would say to expect colder, below average temperatures over the next 2 weeks based on the Teleconnections today. All right, wraps things up. Spot on weather. If we're not spot on, we're not doing it right. Thank you so much for watching this video and subscribing to the channel. We love sharing the weather with you. So take care, everybody. I wish everybody the best of health. Just best of wishes for the new year as well. All right, that wraps it up. Take care, everybody, and have a great evening.